So we now know what we need to know for us to devise our policy. So let's recall that we have a demand that is normal distribution with an average of 1,000 computers per month, a carrying cost of $4,000 per order, and a holding cost of $32 per computer a month. And the lead time for our computers to be received is 0.25 months. And we already calculated that our lot size, our economical order quantity, is a 500. So we need to calculate the reorder points. And as we said before, these reorder points calculated as the average demand during the lead time plus a number of times the standard deviation during the lead time, which is our safety stock. So the average demand during the lead time doesn't change compared to the best bound deterministic approach, which is 1,000 computers per month times 0.25 months, which is our lead time. So on average, you're going to have a demand during our lead time, which is 250 computers. And the key thing here is the standard deviation during the lead time, which is 0.25 months. So as we saw before, we can calculate this as follows. The standard deviation during those 0.25 months is 0.25 times the variance during that lead time, which is 0.25 times 2 to the power of 200 to the power of 2, which is 10,000 computers. That is the variance of the demand during the lead time. And the square root of that value is the standard deviation for the demand during the lead time, which is 100. So when this is our the standard deviation during the lead time, we can perform the following analysis. We will focus on these three lines here, which is the new part of this slide. If we add 1 time the standard deviation to our average demand during the lead time, we have 250 plus 1 time 100, which is 350. In this case, if we use this as our reorder point, which means we place an order when our inventory level reaches this value, the probability of not having stockouts is 84.1%, as given by this table here. If our reorder point is higher than that value, and we have twice the standard deviation during the lead time, which is 2 times 100, which is 200, we will have a reorder point which is 250 plus 2 times 100, which is 450. And the likelihood of us meeting all our demand increases to 97.7%. And finally, if we add 3 times standard deviation to our average demand during the lead time, we have 250 plus 3 times 100, which is 550. And in this case, pretty much always, this is 99.9% of the time, we will be able to meet all our demand. So the larger the reorder points, the larger our safety stock, the more likely it is that we do not have stockouts.